Tell us about the software that you make. So you have a reactive data processing framework. Yeah. Tell us what that means and what can you do with it.
Yeah, sure. So reactivity is all about the art of dealing with changing data in such a way that you don't have to worry too much about the processing part when data changes. I think if you want to be formal, there's probably some dictionary or encyclopedic definition of reactivity, which will tell you it's about being declarative in a programming sense, like explaining the logic without imperatively saying what to do at every step of a data transformation, but of explaining the rules in like a functional programming sense, explaining what the transformation should be. And that's about the essence. So it's really combining the ability to be declarative with the ability to process data changes automatically in an efficient way. So that's a notion known as incrementality. It's the idea that when data changes, you don't have to do a full recomputation of all the models of all the things that you've designed in your data pipeline or in your data science project. You just do a minimal recomputation to react to the way data changes. So I guess the most best known example of a reactive system out there is your spreadsheet. Call it Excel sheets, whatever is your preferred software.
Mm.
You
Hmm.
define the rules on the data, and when the data changes, the cells update. So this is like one
Right.
example. It's a data processing example. It's not one that scales very well, but it's an example of data processing. And actually, since spreadsheets came in, I think nobody has been able to fully replicate the success of this type of approach at scale. And we come with our attempt. I should say that reactivity is a concept that's very well known, very familiar to front end developers.
Right.
If you've worked with JavaScript, TypeScript,
Yeah. It's even probably the most famous framework right now for front end development is called React.js.
it is. And the others that don't have React in their name are reactive nonetheless. So all of them are. And like the kind of place this has got front end developers to is that when designing a front end system, you don't have to do as much event handling as you would do 15 years back. So some of you may remember having to write things like on-click events to describe the state change of a button, when you click, but you had to do it and so on. And these days in front-end development, you don't do it that much. Surprisingly, in data processing, even data processing at scale, if you want to work in a real time setup, you want to work with data that changes or with streams of event data, a lot of the time you still find yourself doing the equivalent of on a click do or something like this. The backend equivalent is on data change event or on arrival of a certain packet of data do. And this is something that has to be done behind the scenes, no question about it. It's just that we don't necessarily want the developer, be it the data engineer or the data scientist, to be exposed to the pain of doing this type of on something event processing after they've already had to put a lot of effort to design their system just to get their job done to create a model or
Hmm.
something. So,
Hmm. So it seems relatively straightforward to me to understand. In the case of a user interface, we have a browser app that is reactive to somebody adjusting how wide the browser is, or whether they come in on a mobile browser or a tablet or a desktop, that the website automatically adjusts, or as you're saying, to behaviors, to somebody clicking on something and the application reacting to that. In the case of data changing, what does that mean? Like, how do the
mhm.
data change that are flowing into a machine learning system? Like the the machine learning system, it could be handling different kinds of data types, or what is it? What does it mean when the data changes?
So the most straightforward setup, I'd say, is when the data type does not change. You just have to deal with new data of the same type, just data that you haven't seen before. If you're a data scientist, like the ideal world is when the data sample that you're working with
Hmm.
is the
Hmm.
actual data that will
Hmm.
be that has to be analyzed.
Hmm.
When you're in the online ever-changing world where new data comes in, this is never the case that the data sample that you look at the time of designing your model is the one for which you need to do the insight. So in some sense, at least the testing data, the real world testing data is not known to you. Sometimes, even in real world scenarios, it may be the case that the training data, so to speak, is not known to you. So your model is retraining itself or adjusting to new incoming data.
Online
Um,
learning.
Online learning and things like this. So this is the general setup. If you like diagrams, you can picture data inputs on the left, data outputs on the right, and your data pipeline in between. And whatever fresh events come in from input need to be taken into account. If you want to make life fun in an architecture sense, you can also put a human in the loop, somebody who's
Hmm.
providing feedback on how your model is performing and saying, actually, we should tweak this parameter. For example, it's like, it's today we need to adjust because it's a rather special day or something like this. Some parameter for your forecasting, prediction, anomaly detection model. Or the user can say, actually, in the training data, there was a mistake. And we need to pull out a training data point and say, look, this should never have been trained like this, or the label should have been changed, or a certain class of automated inputs which entered the system may have entered with incorrect values. For example, there was some confusion between M denoting meters and miles. The data that input needs to be rescaled, and you have to sort of unlearn the data that came in previously and relearn with the new data. So anything is kind of possible in the sense of data changes for the system.
So, in the past on the podcast, we've talked about issues around things like feature drift, where
Mhm.
you design a machine learning model to be able to handle the kinds of training data that it's encountered in the past, but then the real world changes. And so the inputs, the features that are coming into the model, so in your, you described a flow from left to right. So on the left hand side, in those data inputs, the the inputs are fundamentally changing. The structure of the inputs is changing. So even though, as you say, it's the same data type, it's still a 16-bit float value, or it's an integer, whatever.
Mhm.
Um, the um, the features are now in a range that are outside of your training data, because the world has changed. So, is what you're describing, this reactive data processing? It's designed to allow your machine learning models during online learning to be able to adapt to this feature drift automatically.
So this is part of the story. I think reactive data processing should be treated very broadly, and if you start implementing it in a larger system, like data pipelines in enterprise, which are processing event data. The start of the story is in data engineering, the end of the story is in analytics. In order to benefit fully from this type of framework, from real time data processing in general, it has to be put into place like end to end, or at least it helps to put it into place end to end. And the models, the analytics models, the machine learning models that come in are kind of the cherry on the cake, but the one that allows you to do a lot of value. So we make sure to make this possible. This is just to say that in a strictly machine learning context, this would be a very um, let's say, a good application, and at the same time an ambitious one when you get to models which are sufficiently advanced to be very much aware of problems like feature drift versus, let's say, an intermediate class in somewhere in between engineering and more advanced machine learnings of models which have a certain time horizon, a time window in which they learn, and they are updated as this time window moves ahead. I'd say this is like a first more natural example in a real world project that you'll be looking at the last few months of data, some kind of moving average on the data, and trying to adapt to it. So indeed, it may be the case that we get into questions of models getting outdated and needing updating, model versioning, and so on. But this is some heavy machinery which comes in relatively late in the project. A lot of the time, it's actually possible to just adapt to the structure of the data itself by having a model which knows how to adapt to the structure of the data, which has this capacity to encompass horizons, to be somehow scale free with respect to the nature of the data.